So, hey, Alan. Okay, but anyway, I want to mention that for the model building part, I know we'll have 4 days. We might have 5, and you get 10 points a day just for building the models. Okay, and so we might build like 8 models today. We might build 10 models tomorrow, things like that. So I might even do 4 model building, skip a day, come back. But we'll have about 50 points worth of just build the models. You get that? As a matter of fact, if you don't build it right, I'll say no, and you fix it, and I'll say yes. So it's not like you're going to lose points for that. I hope you have the right attitude, because this can actually be fun. I don't think you've had any experience with organic chemistry that I know of. Is that correct? Okay, and so what happens is you know how to name a whole lot of inorganic things, but the way they name organic compounds are different, and I think you'll like it. I think it's even easier than some of the inorganic names. Got it? So I think you're going to like that today. Let's do a quick review, and then we'll start building models. First of all, most of the compounds that humans have discovered are organic. That means they're carbon compounds. And yet, that's kind of weird, because carbon's not that reactive. If you had a bunch of carbon here, it would sit here for a few thousand years, and maybe nothing would happen to it. But it does seem to make a lot of different compounds. And so here's some of the reasons. Number one, first of all, it has 4 valence electrons, so it could actually put 4 different atoms around it, right? That's kind of unusual to have 4 different atoms bond with you at the same time. Carbon can also form bonds with itself, and it can bond in single bonds, double bonds, and triple bonds. It can also make really long chains, and the chains can be what they call straight chains, or they can be branching chains. And they also can make these things called ring structures, and where the carbons form a triangle or a box or a hexagon like that. And as we get more and more into organic chemistry, you're going to see a lot of those ring structures like that. All right, so that's why we think there are so many carbon compounds. All right, what do you call the shape? What would you call the shape of this molecule here? Tetrahedron, which again has a very big shape in chemistry. And so you have your carbon in here and your 4 hydrogens right here, like that. All right, now, what we're going to do here is we're going to build the first model. And you don't know what this is called yet. That's okay. All I want you to do is to build this model here. Now, does everybody know which color on the kit is carbon? Okay, now how many sticks or how many bonds are going to come out of every carbon? Okay, and then you're going to have some hydrogen. How many bonds are going to come out of every hydrogen? White. 1. How many reds? How many bonds for oxygen? Okay, let's go ahead and build this one and also build this one. Okay, so you're going to build this one and you're going to build this one. So one of you could build this one and one of you could build this one. Yes, as of right now, just use the small ones, and you'll find out when you have to use the big ones. All right, so everybody build this, and then build this.
Does the second one have to be like straight?
Okay, now, we mentioned that a little bit yesterday. Everything on paper looks flat, but when you actually build a model, you'll see it's not really that flat. Yeah, you're going to have trouble building a flat molecule. All right, when you have both of them done, hold it up. By the way, chlorine is going to be the green ball with the 1 hole in it. So chlorine is going to be green. All right, when you get both of them done, hold them up. Hey, you don't have to look at the camera. You can look at your own handout sheet, okay? You don't have to look at the camera, but you can just look at your own handout sheet.
So the shape of these, where the holes are located on the carbon, don't like the straight line.
Okay, now, on paper, everything looks straight. But when you try to build it, you'll notice that it's not going to be straight.
Yeah, so that doesn't matter. Also, I noticed that, like,
All right. Can you twist it? Yeah, you go. Very good. That's very fast. Now, hang on to those. Hang on to those. I need 2 of them. That's the first one. I need 2 of them. Hey, when you have both of them done, hold it up in the air. Now, you don't know what these are called. Not yet. Yeah, very good. That's 2 groups. Stay right there. That's 3 groups. A green. You should have a green with 1 hole in it. All right, 3 groups are down. Let me.
I had a question. So for like, I remember when I studied saturated fats, unsaturated fats, it was like then, and then when you heat it up, but then the energy snaps and it becomes straight again.
We're going to talk a little bit about that.
Does that happen with these?
Yes.
Okay.
Okay, wait a minute. That's good.
Are they all bent like this normally?
We'll get to that. We will get to that. For right now, we're gonna. I'm not ready to teach about denaturing. That's proteins usually, but I'm gonna also talk about rotation. And okay, yes. Wait a minute. That's good. All right, got 2 more groups to show me. No, don't take it apart yet. Don't take it apart. Okay, I got 2 more groups. 2 more groups that haven't. I guess that's hurting their hands or something. All right, yes, yes, all right. Okay, that's good. And you guys had the first one done really fast. Okay, I know. Okay, now, don't take them apart. Ready? You got 1 more put in there? All right, that's it. Now, here's what I'd like you to do. Take this model right here, and don't look at the handout sheet, and tell me what the formula is, and you go CHO. Don't look here, and write down somewhere, what would you say the formula was for this model right here, and then write down what you think the formula is here for that one, and again, it's CHO, and then whatever else is left. No, the normal. All right. The first, wait a minute. Hey, listen. I want the molecular formula. I want the molecular formula for the first one and the molecular formula for the second one. All right, don't look. All right. Now I'm going to ask you to do this without looking at the paper. Okay, let's start. Hang on. Hey, everybody stay. Stop. Everybody stop. I'm going to point to a group. You're going to give me an answer, okay? All right, what do you have for the formula of the one that had oxygen in it? CH3. C, only one C?
Yeah.
You're going to give me the molecular formula.
Oh, C2.
Yes?
H6O.
That's it. I mean, CHO. All right, now you give me the formula for the molecular formula for the one that has chlorine in it.
C3H7Cl.
Everybody see that? Now that's the way you would normally do it in inorganic chemistry. Let's kind of do it that way. Give me the C, H, and all like that. Now what I'd like you to do, and you're a little ahead of me, what I'd like you to do now, the way an organic chemist would do it, this is called the molecular formula. Everybody got that? This is called the structural formula, which is like a map of how to build it. So on a quiz, if I say, give me the structural formula, you give me the roadmap on how to make it. See that, like a drawing? But now, this is the way chemists do it because they don't want to take the time. And who wants to do that on a typewriter or on a word processor? Nobody wants to do that, do they? On a computer? Nobody wants to do that. So they figured out a way of doing it, and they just kind of go left to right. And, all right, let's try that. What do you guys have for the graphic formula for the first one? Everybody see that? CH3O, CH3. Okay, what do you guys have, Jonah, what do you have for the graphic formula of the second one? CH3. And then CH3? Okay, everybody got that? So the first thing I want you to know is molecular formula It's kind of like, well, how many C's are there? How many H's are there? How many O's are there? That's pretty easy, right? But it doesn't tell you anything. It doesn't tell you how it's put together. Now, this will tell you how it's put together, but who wants to write that out? And so they came up with their own little way of doing it called graphic formula. Everybody got that? That's the first thing that's going to be different here. Now, the next question. There's another reason why carbon forms so many compounds. And here's this new word for you, and it's called isomers. Now, I know that when we were doing the atom, we had this word that sounded like that. It was called isotope. Remember that? So there's oxygen who weighs 16, and there's oxygen atoms that weigh 18. And they're both isotopes of oxygen, aren't they? All right, that has to do with the nucleus of the atom, doesn't it?
Yeah.
This is not isotope. It's called an isomer, but iso does mean same. See, isotope, same element, different mass. Isomer, same, something's the same. And so what I want to do is, I'd like you to build this one. Oh, I'm sorry. I want you to build this one right here. Okay, so we're going to build this one right here. All right, everybody build that one and hold up in the air, okay? So build, I'll teach you later how to name these. This is called N-butane. Okay, so I want you to build C4H10. Build C4H10. Now you don't have to take the other model completely apart. Yeah, you guys figured it out. That's it. Stay right there. Yes, that's it. That's 2 down. Yes.
Wants to do isobutane as well.
Well, you're ahead of me. You're way ahead of me now. Okay, stay right there. All right. When I ask to do the next thing, you already had done. All right, that's it. C4H10. C4H10. Okay, that's correct. You got 4 more tables. 4 more tables. Hold it in the air so I can look at it. C4H10. Okay, there it's it. Next. 3 more tables. That's it. That's it. Okay. Okay, next. 1 more. 1 more.
Oh, is the other one in?
In just a minute, yeah.
Oh.
See, you guys could invent some kind of a tool to help put these together. Okay, all right. All right, everybody stop. Everybody stop. Now, what I'd like you to do is, it says C4H10, and chances are you built this one. Now, I'll show you a little hint on how to build these. This is called a carbon backbone. What I would have done, if I were going to build this, I would have built that first. That's my backbone. See that? Then I would just put all the hydrogens on there, like that. Now, my question to you is this the only way that you could build C4H10? If you think there's another way to build it now. Okay, no, keep that one. Keep that one. Now build another one. If you think there's 2 ways or 3 ways to build this, hold both of them up in the air at the same time. Wow, that's fast. You guys, that was very fast. Yeah, you're way ahead of me. If you think there's more than 1 way to build it, hold them up in the air. Maybe there's 3 ways. Well, you can go back and get some. If you need more sticks, there's more sticks back there. Okay, now right now only one group has shown me this.
This is our second one. We took our first one.
Okay. That's one of them. Where's the other one? Okay, that's it. Keep those. Hang on. All right. 2 tables are done. 3 tables are done.
And then 8. 1, 2,
Okay? Think about the backbone. Think about whether the backbones are the same.
Each one's gonna need to have, we don't, in the cupboard's not gonna have a spot fill. Because then the valence shell don't fill, so I'm just putting it.
Okay, that's it. All right. Keep going. Okay, now, if you, listen up. If you have both of these built, and I said okay, now what I want you to do is to write the graphic formula of each of those things you made. See if you can write the graphic formula. Now, if you haven't held up in the air, then you might not have the right model, so that's one of them. Okay, now write the graphic, yes, that's one of them. Where's the other one? That's it. Okay, go ahead and write the graphic formula. Okay. And, okay, go ahead. You can go left to right. Okay, what do you think? All right, everybody, let's everybody stop for a minute and stop building models. Everybody stop building models. It makes a lot of noise. Let's see. Carson, tell me, what do you have for the graphic formula for this one right here?
CH3, CH2, CH2, CH3.
CH3, CH2, CH2, exactly right. All right, go ahead and give me this one.
CH3, CH3, CH3.
Okay, now I'll tell you why that's not confusing to an organic chemist. An organic chemist knows that this is on the end, CH3, everybody see that? And then they know that this C was only attached to one H, so he was attached here, wasn't he? He was attached here, but then he was attached to an H, and then you normally would never see you don't see any CH3s in the middle, do you? The only time you're going to see a CH3 in the middle if it's a branch. This is called a straight chain. See the carbons? Straight chain. And this is called, look, 4 in a row, 3 in a row with a branch. Straight chain, branching chain. Everybody get that? Okay, so we have, is there any other way to make this? Is there or not? Even though it's not on the paper, is there another way? Anybody want to make it? Okay, actually it's not, but that's all right. But anyway, what I want to show you, wait a minute. What is this, butane? I got to be careful what I just said there. No, okay, no. Anyway, so what we had is isomers are really big. And let me show you this. It said here, see if you can draw, now we're going to do it later. We're going to do this later. Later we'll do this, but see if you can draw the isomers of pentane. We're going to do that in just a second. But here's a fun fact. If you had not 4 carbon atoms, but we had 20. If you had 20 carbon atoms and 42 hydrogens, how many ways could you make them? How many isomers are there of this compound here? 360,000 ways. Do you understand why there's so many organic compounds? This is just 20. That's only 20 carbons. What about 30? What about 45? So the number of isomers is huge, isn't it? Now what I'd like you to do, no, I don't want you to build a model, but I want you to take your pencil, and what I'd like you to do is try something. 1, 2, 3, 4, 5. Now, did everybody see that? There's my 5 carbons. Now, do you know how many hydrogens I can put on this? Watch now, watch, ready? Carbonize 4 bonds, ready? 1, 2, 3 more hydrogens, ready? 4, 5, 6, 7, 8, 9, 10, 11, 12. That's why it was C5H12. Everybody see that? Now here's my question for you. I don't want you to make the model. I don't want you to draw the hydrogens. That takes too long. But how many isomers are there of C5H12? Okay, and that's a drawing. I want you to draw on your paper. Here's one of them. We're going to do a lot with isomers later. We're just scratching the surface today. Is there another way to line up your carbon atoms besides 5 in a row? So try it. Is there another way to line up 5 carbon atoms and still have room for 12 hydrogens? And I don't want you to make it. It takes a little longer, but I want you to draw it real quickly. So we have these 5 in a row. That's one of them. Now, I want to give you, when you tell me how many more you can make, we'll stop and I'll tell you what the answer is. But how many ways can you make C5H12? And all you really have to do is draw the carbon atoms. But you got to make sure that you still can put 12 hydrogens on there. There's one of them. But, all right. Anybody have a number yet? Does anybody say it's only 1? Anybody think it's only 1? Anybody think it's only 2? Some say it's only 2. Anybody 3? Does anybody ever come up with 3? Anybody come up with 4? More than 4? Raise your hand if more than 4. More than 4. How many do you have? 5? 5? That's called peer pressure. He wants to say 5. What do you want to say? You say 1. All right. You should. Stand up for yourself, okay? Good. 2. Anybody have, if you tried to draw these, how many ways could you draw it? Okay, so I need to show you a little bit about organic chemistry that you might not know. For example, let's take a look at this little guy here. See this little guy here? I didn't put all the hydrogens on there. They kind of get in the way. But let's just pretend those are hydrogens, okay? All right, now, even though this is 3 carbons in a row, right? If I go like this, it almost looks like they're in a row, doesn't it? See? But on paper, it looks like they're straight. But even though they're not straight, are they? Aren't they bent? Okay, so that's what I like about model building. It tells you a little bit more of what's going on. Now, here's another problem. Watch this. See this? Watch this. Okay, now this was in the reading material you had, but what I could do is I can try to twist these. Like, for example, what if is this another compound? What if I don't put the chlorine here, I put it over here? You mean like that? Yeah, is that different? It's not. As a matter of fact, a single bond is able to rotate. So it actually is not a new structure. Okay, it can rotate around a single bond. So anywhere on the end is the same thing. But what if I put this chlorine over here? Would that be different? Would it? Oh, you tricked me on that one. And so they don't have a left and right, do they? And so that's not a different compound either, was it? But what if I were to put the chlorine here? Is that different? It would. There's no way I can just rotate and get those. So the first thing I want you to know is that even if you had a straight chain, you had one. EJ, hold that up near. Now, bend it, would you? Bend it around. Is that different? No. So what happens is they can actually twist along a single bond and still be the same compound. Okay, here's another one to teach you, all right? Now watch. We learned up here that you could have either 4 in a row or 3 in a row with a branch. Okay, so we learned that you could have either 4 in a row or 3 in a row with a branch. But could you have made a branch up here? could you have made a branch like that?
No, you don't have 5 carbons.
I mean, up here. If I wanted to make, you said there were only 2 of these. What if I built that? Would that be another isomer? And the answer is no. You know why? Because all I did was take this, and what I do? I just flipped this guy down, didn't I? So you can't have a branch on the last carbon. You cannot call that a branch. He's still part of the straight chain. See that? One more time. You can't have a branch here, and you can't have a branch here. That's just going around. That's 4 in a row. This is not 4 in a row. This is 3 in a row with a branch. All right, so when you told me you made this one, right? What's another way? Is there any more you can do with 5 in a row? No. There's no more. How about 4 in a row? Now you got to put one more somewhere. So what do you think? How about here? Is that an isomer? No, that's just going around the corner, isn't it? How about here? No, what? No, yeah. How about here? Ooh. Okay. What do you think about that? Is that an isomer? What if I didn't put it here? I put it up here. Not an isomer. What if I put it here instead of here? One more time. What if I put it here instead of here? What if I put it here? See? And that's the kind of thinking you're going to be doing when I do isomers. Now, we're not into heavy-duty isomers right now. We'll do more isomers later. I just want to see how many you came up with. So you said 5 in a row. Check, check. How about 4 in a row with a branch? Okay, now, what about 3 in a row? You already told me you can't do 4 in a row. You can do 4 in a row with one branch, but there's only one with those. How about 3 in a row? What about 3 in a row? How about here? No. How about here? How about here? Oh. So if you are reading that packet like you're supposed to at home, you know that they talked about butane having, pentane. You know that. I'll show you the name in a minute. They told you that there were 3 isomers of this guy right here. The straight chain, the one that's 4 in a row with a branch, and this one right here. Remember that? You remember reading that somewhere? Now, again, if you go back and read it again, you say, well, now I understand what they were saying there. You get it? Now I'm going to try to help you understand that pack a little bit too. All right, so questions on that? All right, you did a great job. Let's build some more models. Ready? Let's go to the next page. Yeah, but hang on. I'll tell you what I wanted to make, okay? I want you, let me tell you some lingo here, a little vocab. Now, I'm going to start telling you how to name. I didn't even name any of those things on the first page, didn't I? I never even named them, did I? We're going to start naming some compounds. All right. First of all, compounds that contain only carbon and hydrogen are known as Jerry's. No. Jerry graduated a couple years ago. No, what are they called? Hydrocarbons. Okay, so we're going to start building some hydrocarbons. Okay, now, a hydrocarbon is in which all the carbon atoms have 4 single bonds is called a saturated. Does everybody know if it rains a lot and the ground can't hold any more water and that means it runs off? They say the ground is already full, isn't it? It's full, it's saturated. And so in chemistry land, if your carbons have 4 single bonds, he's put the most amount of atoms he could around it, couldn't he? And that's called a saturated hydrocarbon. Now, they have a fancy name for a saturated hydrocarbon, and we'll get to those in just a minute. But a hydrocarbon that contains a double bond or a triple bond, that carbon did not put the most around. See, if you have a double bond, you didn't put 4 atoms around you, you only put 3, didn't you? So that's called an unsaturated hydrocarbon. Everybody with me? Now we're getting ready to do the saturated hydrocarbons first. Yes?
So a carbon that's part of a backbone, is it saturated?
Okay, if the carbon in the backbone has 4 single bonds, every one of them, then it's saturated hydrocarbon. If it's only made of carbon and hydrogen, and all of them are single bonds, and that's what we're going to do. We're going to do a whole run of hydrocarbons that are saturated. They have a fancy name for that. Now, here we go. They're called the alkanes. Now, the alkanes are saturated hydrocarbons. This is called the alkane series. All right, what I'd like you to do is to build the simplest hydrocarbon you can think of. Build the simplest hydrocarbon you can think of. Do it now. You're fast. You're very fast. You're fast. You're fast. You're fast. Wow, you pick up on this very, very well. That's it. That's it. Hey, no pressure. No pressure. No, wait. You need pressure. No. Wait. That's it. That's it. That's it. All right. Everybody stop. Now I'm going to tell you how to name this, okay? I love the way they name certain things, especially alkanes. And let me show you what happens. If you are a saturated hydrocarbon, you will always end in ane. But if another way of saying you have one carbon is the word meth. Meth means you have one carbon. One carbon. If you have one carbon and you're saturated hydrocarbon, methane. Methane. So what you just did is you've made methane. Now methane's a gas that if you go to some really yucky, mucky places, swamps and things like that, sometimes I've walked along places and when I stand on the ground, you might even see little bubbles come in the water. And there's a lot of these bacteria down there and they don't have a lot of oxygen and they can actually make methane gas. So sometimes they even call it swamp gas. Now, if I want to make some methane, I just go to Taco Bell and get the $5 special. And usually within an hour, I can make some methane gas. So, but anyway, humans, the bacteria in humans can make methane gas. And you know, I should turn this off, but I think I'm okay. I'm not crossing the line here. But one time in my life, I remember a person who lit that. And I was only about 14 years old, but I will never forget it. And I'm very old now, but I still remember the person who lit some methane gas. And it does light. It actually will come out like a little flamethrower and everything. Okay, so that didn't cross the line there. So methane is the simplest hydrocarbon. And, oh, now you get it. Okay. It's the simplest hydrocarbon, and it is a gas at room temperature. It is a gas at room temperature. And by the way, all hydrocarbons are flammable. All hydrocarbons are flammable. Okay, ready? Now, what you're going to do is you're going to come up with your own little memory trick for the first 4 of these. And the one that I will teach, if you don't like it, that's okay. Now, if you know somebody named Margaret and you know that every day at lunch they eat peanut butter, then you can say Margaret eats peanut butter. And that's going to remind you about the first 4 in the series. Mother eats peanut butter. Mary eats peanut butter. And what I want you to do is remember meth, eth, prop, bute. Everybody got it? Okay, ready. Make ethane. Make ethane. Man, you guys are ahead of me. Make ethane. Diane, I can't believe it. Good, good. Yes, yes. Ethane, 2 more. That's it. That's it. Now, stop. Stop. I know you're trying to get ahead of me. Wait, stop, stop, stop. Ready. Give me the molecular formula for ethane. Molecular. Calvin. Wait, Calvin? I can't hear you. Oh, you're talking about ethane. Yes. Okay, have I got that? Now, Calvin, give me the graphic formula for ethane. Look at your model.
C3C3 CH3, CH3.
That's right. That's right. Everybody get that? All right. Now, it just so happens that at room temperature, ethane is also a gas. Okay, let's build propane. Okay, you're ahead of me. Okay, good, 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 good. Now, if you've already built it, go ahead and tell your partner what is the molecular formula and what is the graphic formula. So let's make propane. Do the molecular formula. Okay, that's it. All right, tell each other what is the molecular formula. Who have I not called on yet today? Caroline. What is the molecular formula for ethane? Everybody here? Can everybody hear that? Say it again.
C3H8.
What is the graphic formula?
CH3, CH2, CH3.
Okay, now, I know what you're thinking, but you're wrong. I'm actually wanting you to see a pattern. Now, some of you have not seen a pattern yet, but I want you to look for a pattern when we go to the next jump, all right? And by the way, propane is also a gas at room temperature. Let's make butane. Very good. And you now know there are two different isomers of butane. That's it. That's it. Yes. 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 Okay, yes. All right. How about butane? Butane. Okay. Two more groups. Butane. Is that it? Is that butane? Okay, now, Kyle, I haven't called you yet. Kyle, what is the molecular formula for butane?
C4H2.
Okay, what is the graphic formula?
CH3, CH2, CH2, CH3.
All right, looking for a pattern. Now, before I jump to the next one, and some of you haven't seen a pattern yet, that's okay. That's okay. I know what you might be thinking. Oh, I bought a butane lighter once, and I think you made a mistake here. That butane lighter, I saw it. It was liquid. I saw it. You could see through the lighter. You could see through it. Yeah. Anybody had a butane lighter before? You saw it liquid, wasn't it? But I'm telling you a lie, then, aren't I? Now, actually, at room temperature, normal pressure, it's a gas. But what did the lighter company do? They put it under a lot of pressure. And they put the gas under a lot of pressure, turned it into a liquid. Do not try to explode a butane lighter. It's under pressure. You get that? I've seen people do that. You see all kinds of things on YouTube, but if you try to break open a butane lighter, like with a hammer and nail, you better be ready. It's under a lot of pressure. You get it? All right, so it's really it looks like a liquid, but that's because it's under higher pressure than normal atmospheric pressure. Okay, one more. Let's do pentane. Go. Now, if you've already built pentane, that's 2 tables. If you already built pentane, talk to your partner and say, what's the molecular formula? What's the graphic formula? That's it. Okay, now. Pentane. Yes. Yes. Okay, let me see it. That's it. Now unwind it a little bit. Okay, there you go. That looks good. That looks good. That's good over there. Alex, that's good. All right, now, let's see. Wait a minute. Wait, don't go any further yet. Isabel, I haven't told you. What is the molecular formula for pentane?
C5H5.
And what about the graphic formula?
CH3, CH2, 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 CH3.
Okay, now, everybody look up here. Look up here. Finish this. What would the molecular formula be of a saturated hydrocarbon that had 100 carbons in it? You're not going to build it. Now, if you haven't seen the pattern yet, that's okay. I'll tell you what the pattern is. But if you don't see it, if you saw a pattern, you could finish the sentence. Saturated hydrocarbon with 100 carbons, what would the molecular formula be? You should be proud if you see the pattern. If you don't, I'm okay. Don't say it out loud. All right, write down what you think the answer is. Write down what you think the answer is, and then we'll see if you saw the pattern or not. All right. Did everybody write an answer down?
Yes.
Okay, don't say it out loud. Don't say it out loud. Wait, I'll tell you what. We will do it out loud. And just tell me what you write down.
C100H202.
How much?
C100H202.
202. 202? Really? Okay, so you saw a pattern? Okay, I want you to think about this because we're not just building models. I'm trying to give you an idea here. If you look at that model right there, did you notice that, look at the pattern here. For every 1 carbon, there was 4 hydrogens, right? But then I went to 2 carbons. It didn't double to 8. And we went to 3. So what is the pattern here? What's the general pattern? What is the general pattern for all saturated hydrocarbons? N means number. So pick any number of carbons you want. How do I mathematically figure out what this number is going to be? Somebody said it. What is it? And of course it's down here. I'm sorry, it's right. Where am I? It's right here. But if you didn't look down there and you figured it out on your own, that's great. Now I'll tell you why. Let me tell you why it's that way. Ready? Except on the ends. Except on the ends, every hydrocarbon, what do you see in the carbons that are in between? CH2, right? There's always twice the number of carbons in the middle. But on the end, what do you see? Not 2, but there's an extra one, isn't there? Extra one on this end, and it would be CnH2, 2n, except there's 2 extras, aren't there? And that's where you get the plus 2. And so when you're building it, let's do the graphic formula. And chemists are not stupid, okay? I'm not going to write this out. Here's how they do it. CH3, CH2, CH3, but they're going to put a little subscript here. How many of these are going to put?
For that one, which one? For 100? No.
98. So what they're going to do is they're going to say, I'm not writing that out, you silly. I'm not doing that. So they write CH3, CH2 in parentheses, a 98. It means there's 98, see, whatever's in there, multiply that 98 times, and then CH3. That's kind of stuff, that's kind of neat stuff that organic, I think they learned a lot of mistakes from inorganic chemistry. Said, hey, let's try to make this right. Let's try to do this right so it kind of makes sense to people.
Is there an actual hydrocarbon nowadays?
Oh, for sure. Yeah. I don't know the limit of the hydrocarbon world. That's a good question.
Can they get to the point where they're almost?
I mean, again, there are organic chemists all over the world, and I'm sure that some companies are willing to pay money and say, what can we do? You know, what if we were to build the next hydrocarbon? What if we find out it was the best fuel in the world or something like that? I don't know. I actually don't know the limit of hydrocarbons, if there is one. All right. Now, I want you to do, let's do one more. Let's do one more, and then I think we'll clean up today, okay? All right. Here's what I'd like you to do. Maybe 2 more. I want to start the, we want to start the next series of hydrocarbons, not the alkanes, but the alkenes. Now, an alkene is a hydrocarbon, and I'm going to limit it to right now, I'm going to limit it to 1 double bond. So what I'd like you to do is you can use 1 double bond. That'll make it unsaturated. And I want you to make, ready? Make methene. Go. Methene. Hold it up in the air as soon as you get it. Methene. No. Methene. 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 Nobody's done it so far. Methane. No, that's got chlorine in it. That one's got chlorine in it. That can't be right. You gotta put a double bond. You gotta put a double bond in there. Methane. You win. You win. There, you can't make methane because there's nothing else to form a double bond with. So what is the simplest alkene that you can make? Ethene. Make ethene. That's it. Very good. Now you're ahead of me. Ethene. No, that's no, you can't have any open holes. No open holes. That's it. And now some of you figured out what those skinny. Some of you have figured out what the skinny things are for. That's it. That's it. Ethene. Okay. Here's what I'd like you to do. Wait a minute. If you that's ethine. Now, wait a minute. What I want you to do is look to see what number you have, what number kit, because any mess you made, that's your mess. So make sure you get the same building kit and mark it on your paper, whatever. Please continue to read. Read your packet. Read your packet, okay?